So we continue talking about sets, and right now we will talk about Venn diagrams, which we usually use to represent sets and to visualize them. So the question we would like to discuss is why Venn diagrams, if we use circles, have their limitations. So we all know how to draw the Venn diagrams for n1, 2, 3, and for 4, I think, Yannick, you drew here a diagram. Well, that's a good try, but do we have all possible subsets here in the diagram?
So we should have 16 different regions because that's 2 to the power of 4.
That's right.
So for each circle, it can be either inside or outside.
Yeah, so if you look here, it's 1 and 2, right? 1, 2, 3, and 4. 1, 2, 3, 4, 5, 6, 7, 8. 8 regions. So in the Venn diagrams, we need, if we have n sets to represent, we need to represent 2 to the n regions.
Why not?
Because like in the problem with cantaloupes, dates, apples, and blueberries, we can have different type of people. And if you take a person, he has 2 options to either like apple or not, either like blueberries or not, and same for dates. So together we get 2 to the 4 options. So we can create 16 possible types of people.
Yeah, they depends on how they like apple, blueberry, cantaloupe, and dates, right? For each person, for each fruit, he has 2 choices, right? So you can make 16 type of people.
Yes, and we try to draw a possible diagram with 4 circles, and if you count regions in this diagram, there will be only 14.
And then for the others, we can see they do satisfy your requirement.
Yes. So is it possible with 4 circles to create 16 regions? If I could manage that, then I can have a Venn diagram with 4 circles. So that's why we have here the sequence 2, 4, 8, and it seems like 14 is the maximum that we can achieve with 4 circles.
Why?
Why? To do that, we need to count how many regions appear whenever we draw n circles, right? So suppose we have some circles that are drawn, like here, 2 circles. And I try to draw a new circle over here, right? It's going to intersect each circle in 2 points, or in at most 2 points. So here I have 1, 2, 3, 4 points of intersections, right? Because I have 2 circles, at most. So now, if I start going clockwise, whenever I intersect a circle, I create 1 region. There was 1 common region, here I created +1. Here, when I intersect, I created +1. When I go farther, I create +1, and when I go here, I created this region, which is +1. So every time that I intersect my circles, I create +1 more region. As you can see, we had 4 regions, +4, I created 8. If I try to draw a circle here, how many times, how many new intersection do I create?
We can only intersect a circle twice, so it's 2 times 3 equals 6.
So +6 new intersections.
Or on this new circle, right?
Yes. Which means I'm creating 6 new regions. So that's why from 8 I can go up to 14 at most. And you can guess what will be the next. If it's 5, what will be 14 plus
8.
2 times 4 previous circles, which is 22, right? So if we try to use circles to represent our sets, we can represent only 3 sets at the most.
Yes, and if we like don't use circles instead of using ellipses, we see like we can intersect like 2 ellipses with 4 intersections, which means that opens a new possibilities for creating like Venn diagram for higher level sets. So here is an example when n equals 4, and we see that these two ellipses intersect 4 times. Therefore, we created 2 extra regions that we need for n equals 4.